Aloha and welcome to Module 2, all about motherboards. Without further ado, let me bring up our slide deck. And here we go. So Module 2, we're going to be talking about, obviously, motherboards. I want to go over this. It's going to be the part 1 is going to be CompTIA A plus Core 1, 220-1101. And our module objectives here are, by the end of the module, we should be able to describe and contrast various types and features of motherboards, configure a motherboard using BIOS UEFI firmware, maintain a motherboard by updating drivers and firmware using jumpers to clear the BIOS UEFI settings, and replacing the CMOS battery. And we're also going to be working on selecting, installing, and replacing a desktop motherboard. So motherboard types and features. A motherboard is the most complicated computer component. It's one of the first items to consider when building a computer. Honestly, I think it's the second item I normally consider. The first one is the CPU, because the CPU is going to drive what motherboards you can use. And often it's, if you're a gamer or somebody that's really looking at performance, you're going to be looking at the CPU first, and then figuring out what motherboards support that, figuring out the reviews on the motherboard, seeing which one you like the best. So but the motherboard is one of the first things you consider. I just think it happens to be number 2 and not really number 1. So the following things are what we consider when we're purchasing a motherboard. One is the form factor. You've got several different types of form factors. If you already have a case in mind, that may limit your form factor. I would suggest that's not the most important thing, but for some people it is. The processor socket, the chipset, the expansion slots, other connector slots and ports, all these are things to consider. The big one that they haven't put in here, which I personally consider every time, is cost, but each to his own. So the motherboard form factors. Motherboard form factors determines the motherboard size and the features that make it compatible with power supplies and cases. The most popular are ATX, micro ATX, extended ATX, and mini ITX. So the ones you're going to mostly deal with are probably going to be the ATX. The ones that I have most experience with are ATX, then the micro ATX, and some people like to get into specialties like the mini ITX, or if you're dealing with large workstations, really expensive stuff, you might deal with the extended ATX. So the following slides show a few examples of form factors and comparisons of sizes and hold positions of several form factors. So right here, we're looking at the Asus Prime Z590A motherboard, and it has the ATX form factor. If we look at the next page, we're going to see a mini ITX motherboard. Notice this is our smallest one right here. And I believe we have a diagram of what that looks like. So the ATX is this full-size motherboard, then the micro is going to be slightly smaller. Micro ATX, I actually have a couple of systems that use the micro ATX, and it's really a wonderful almost like a book size computer. And I really do love those little systems, like the HP Elite Desk, I think is the one that I personally use. And I really like that. And then there's the mini ITX, which is even smaller than that. And of course, when you look at it, these black spots are going to be the holes where your screws are going to be. So this is how you're going to fix that to the case. So yeah, this is what those configurations look like. But you get an idea of what the relative sizes are by looking at this. So Intel and AMD chipsets and processor sockets. So a chipset is a set of chips on the motherboard that works closely with the processor to control the memory, the buses on the motherboard, and some of the peripherals. And it must be compatible with the processor it serves. A socket is a rectangular with pins or pads that connect the processor to the motherboard. It's essentially the base that you plug the CPU itself into. So the two major chipsets and processor manufacturers out there right now are Intel and AMD. It's been that way for most of my life. AMD came in a little bit later. Intel's always been there. Intel I personally think of it this way. Intel is the stodgier business minded CPUs, whereas the AMD is more like the home market in a way. But AMD makes some really respectable stuff, and a lot of gamers love the AMD brand. So it's usually, I think the Intel usually runs a little bit more expensive than the AMD. But yeah, AMD is quite popular in the gaming community. So some of the latest Intel chipsets include the following: the 600 series desktop chipsets, the 400 and 500 series desktop chipsets, also the 300 and the 200, and the sockets for those are the LGA 1700, the LGA 1200, and the LGA 1151. And here is what the LGA 1200 socket looks like. So this is the socket right here that I mentioned. This is what your CPU will plug into. So you've got all the different pins on the CPU, and they are going to fit into this. And then this, it comes down on top of it and locks in over here on the side. So the LGA 1200 is compatible with the 11th and 10th generation Intel processors. Then on the other side, we've got AMD. AMD has 4 chipset and socket categories. The STRX4 socket, which is used with the TRX40 chipset. You got the TR4 socket for the AMD X399 chipset. You got the AM4 socket and chipsets that are used with the AMD Ryzen and Athlon processors. And then you got the AM3 Plus socket that's used with the AMD Piledriver and Bulldozer processors. And over here, we can see the STRX4 socket that supports 3rd generation Threadripper processors, which are some of the most popular ones out there. And they have the TRX40 chipsets. So to match a processor to a motherboard and socket, you need to do the following. You look at the motherboard manufacturer's website or user guide for a list of the processors the motherboard supports. You can also search the Intel or AMD website for the exact processor to make sure the socket it uses the same as the socket on the motherboard. Honestly, when I'm building a system, I don't do it this way. I go out and I find the CPU that I want to be using, the speeds that I can afford and everything else. Then I take that, then I look up what motherboards are compatible with it. And if it's compatible with it, if you read reviews on it and everything else, you find the motherboard that works with it, and it's going to be compatible. So this really, I don't think is terribly useful, but yeah, from the way I've built, I kind of look at the opposite way. So buses and expansion slots, fine lines found on the top and bottom of the motherboard are sometimes called traces. These traces are the circuits that enable the data instructions, timing signals, and power to move from component to component on the board. And a bus is a system of pathways used for communications and the protocols and methods used for that transmission. And a protocol is simply a set of rules and standards that any two items, any two entities use for communication back and forth. So for buses and expansion slots, we have the PCI Express. So PCIe currently comes in 4 different slot sizes. They're known as PCI Express X1, X4, X8, and X16. So the number after the X refers to the number of lanes that you have available for data. So a PCIe X4 contains 4 lanes, and an X16 slot has 16 lanes, and it's primarily used by graphic cards that need a lot of throughput. So in addition to that, we also require a lot of extra wattage for those cards, and the card may have 1, 2, or even 3 connectors to connect the card to extra power. So those are things to consider also when you're looking at your power supply. And over here, we have a picture of the PCIe 1 and the PCIe 16, and also the conventional PCI slots. So if you look up here, these tiny black ones, those are your PCIe slots. The red ones there are your PCIe 16s, and the long black ones at the bottom here are the 2 standard PCI slots. And let me go back, actually. You'll look and see that if you look at the different, you can see that there's a key in the middle of like the black, the PCIe. You can see that the key is right there around the middle. But if you look at the red, you've got maybe in the top 1/8 or so of your of it, you see the key is right there. And then if you look at the black ones, at the bottom, the PCIe slots, or I mean the standard PCI slots at the bottom, you'll notice that the key is all the way over on the right side. So that's something also to remember to differentiate. So continuing on, the conventional PCI slots and buses are slower than those of the PCIe. The PCI bus transmits 32 data bits in parallel and operates at about 500 megabits per second. They're used for all types of add-on cards. You also have onboard ports. The integrated components are the ports coming directly off the motherboard. So if you look at the back of your system, you'll see a lot of things. You'll see integrated like the USB, the PS2 mouse and keyboard. PS2 mouse and keyboard, is that really still a thing? Anyway, PS2 mouse and keyboard, your integrated video, your sound, your network, your eSATA ports on the back. You're also going to have an I/O shield, which is a plate with the holes for all those different I/O ports, and that's going to fit over everything. So you need to keep that in mind too. Usually when you buy a case, your case is going to have the shields that come with that. And a motherboard may have several internal connectors such as USB, M.2, SATA, and PCIe connectors. So SATA stands for Serial Advanced Technology Attachment, or Serial ATA. It's an interface standard used mostly for storage devices. The current versions are SATA Express, which is SATA E, or SATA 3.x, and SATA 2.x. And then you've also got SAS, which is Serial Attached SCSI, and that's the successor to SCSI from the old days. Then you've got M.2, and that's what was formerly known as the next generation form factor. It uses PCIe, USB, and SATA interface to connect a mini add-on card. And then the motherboard may have USB headers used to connect a cable from a motherboard to USB ports on the front of the computer case. And if you ever have any of those USB ports on the front go bad, you can also use those headers to connect third-party USB ports on the front end too. I've done that in the past. Here we're looking at the M.2 slots. You've got two different types. Well, three technically. You've got the B key, the M key, then you've got a B and M key. And if you notice, the differences are 6 contacts versus 5 contacts. And then you can have one that combines the two, which they call the B and M key. And it has the 6 on one side, the 5 on the other, and then a big fat one in the center. And this one can work supposedly with both. So yeah, so that's the different types of the M2. And then using BIOS UEFI setup to configure a motherboard. So firmware on the motherboard is used to do the following. It can enable or disable a connector, a port, component. It can control the frequency and other features of the CPU. It can manage security features, controls what happens when the computer first boots up, like your boot order, things like that. It can monitor and log various activities of the board. Also, it says here, motherboards made after 2012 use BIOS or UEFI firmware, and UEFI. It's strange. Nobody really knows how to pronounce this. UEFI, the Unified Extensible Firmware Interface. It improves on BIOS, but includes BIOS for backward compatibility with older devices. Essentially, UEFI is a lot prettier than the old BIOS, which, yeah, still is around, but it's pretty hideous looking compared to the nicer interfaces of the UEFI. So, facts you should know about UEFI include the following. Microsoft requires it in order for a system to be certified for Windows 10/8. UEFI is required for hard disks larger than 2 terabytes. And it also offers secure boot, which prevents the system from booting up with drivers or an operating system that is not digitally signed and trusted by the motherboard or computer manufacturer. And for backward compatibility, UEFI can boot from a MBR, the master boot record hard drive, and provide a BIOS boot through its compatibility support module CSM feature. And keep that in mind moving forward. So when you access the BIOS UEFI setup program by pressing a key or combination of keys during the boot process, For most motherboards, you press F12 or delete. This is probably the time you'll do the most cussing during your setup, because in the old days it was F12, it was delete, or it was F2, or it was F6. And every single time you go through it, you have a very limited amount of time to hit those buttons and get it right. They get the timing just right, so you'll enter into your BIOS. But yeah, that's always been a challenge, and it varies from manufacturer to manufacturer. So that's always entertaining. And also, you've got to see your documentation for your motherboard or watch the screen near the beginning of the boot. That's usually when it comes up. It's going to be quite fast where it will tell you that. And you'll also find the documentation for your motherboard. If it's a system like a Dell or an HP or something like that, you'll be quite frustrated to see that there are many different answers to that question. Some will be like, oh, it's F6, others are F12, F11. It's a variety of things. And they never seem to have the one specifically for your model number written down. So it's really just a hunt and peck kind of thing, figure it out, but you're going to be rebooting your system over and over in the process. So after doing this, the setup screen appears with the menus and the help features. And this right here looks quite familiar to most people, I would think. It's a BIOS UEFI setup screen showing a list of drives installed in the system. So if you look in there, it's got the chipset SATA mode. You can see SATA port 0 has a Kingston drive on it. And you look at that, it's 120 gigs. You probably, yeah, you've probably got some type of a small solid state drive there. Then you've got the ST1000. So that's, yeah, that's a terabyte there. And then you've got nothing on port 2, and then port 3, you've got CD DVD combo there. So you've got your optical drive set up. Then you can also set the boot priority in BIOS. So if you want to boot from USB or something like that, you can go in here and change that. You can access a lot of different things. You can do fast boot. You can boot from USB. You can do a PXE boot to LAN. Yeah, you've got all types of priorities that you can set your boot order to, so that you make sure that you try one before you go to the next, before you go to the next. So this is often when you're first setting up your system and you're putting an operating system on it. And then if you look down here at the bottom, you've got all these other options, and you always remember your save and exit. And yeah, you can also return to defaults. So managing secure boot. Secure boot was invented to help prevent malware from launching before the OS and anti-malware software is launched. So secure boot works only when the boot mode is UEFI and not CSM, and the OS supports it. It's supported by Windows 10 and several distributions of Linux. Secure boot holds digital signatures, encryption keys, and drivers and databases stored in flash memory on the motherboard and or the hard drive. And when it's enabled, it's going to check each driver, the OS, and applications before UEFI launches the programs to verify that it's signed and it's indeed correct. And it's that they're also listed in the secure boot databases. So that will, yeah, that'll come in very handy to keep you from being hacked. So here is the screen that deals with the security. And you can look in here at all the different options that you have for secure boot. You can set your administrator password, your user password, password for hard disk itself. So there's a lot going on here. You can set your secure boot to enabled or disabled. It shows your status there. So yeah, there's a lot of nice security features here. And this is obviously a little bit prettier. This is a UEFI, the UEFI interface, and this is giving you very similar things here. So it says use CSM to boot a legacy BIOS system or disable it to implement UEFI. So you look in there, you can do fast boot disabled. You can set different things for your logo display, your numlock state. Wait for F1 if you've got an error. So all these settings you can set in here. Then configuring your onboard devices, you can enable or disable some onboard devices using your BIOS UEFI setup. For example, your network ports, your USB ports, and your video ports, you can turn them off. You can disable them in your BIOS so that you're not going to have access from the operating system. And what you configure depends on the onboard devices the motherboard offers. Obviously, if your motherboard doesn't have it, then you can't really turn it on or off in the BIOS. One possible setting you can change is USB power share, which enables you to, it says change a USB device even when the computer is turned off. This is actually supposed to be charge a USB device. So when you've got USB power share going on, you can charge let's say, plug in an iPhone or something like that and charge it while the computer is actually turned off. You can also do overclocking on your processor, your memory, motherboard. Overclocking is running a processor, memory, motherboard, or video card at a higher speed than the manufacturer recommends. It's not a good idea to do this. I know a lot of gamers do it and would probably argue this, but you're putting a lot more stress on your CPU and your equipment, and that leads to earlier failure rates. So it's something to consider when you're going to be doing that. Also leads to some you may get better performance, but you may get some instability as well with that. So it's not recommended that you overclock your CPU. Also, back in security, kind of touched on this. You can set your supervisor and user passwords to help lock down the computer. This is something that you should definitely consider doing. Just make sure you don't lose said passwords. So you can also set drive password protection. Some motherboards allow you to set a password in order to access the hard drive. It doesn't encrypt all the data on the drive, but encrypts only a few organizational sectors on there. And then you've got the TPM chip and hard drive encryption. So many motherboards now contain a chip called the TPM, the Trusted Platform Module chip. If you're going to be taking the CompTIA Security Plus exam, you're going to be hearing about this there as well. You've also got the BitLocker encryption tool in Windows that's designed to work with this chip. And you've got the BitLocker encryption key, the startup key, which is kept on the chip. And this method assures that the drive cannot be used in another computer. So that's nice. Then we get into virtualization, which is another thing you can set in BIOS. So virtualization is when one physical computer uses software to create multiple virtual machines. So a virtual machine simulates the hardware of a physical computer, but each VM works like a physical computer, and it's assigned virtual devices such as a virtual motherboard and a virtual hard drive. And the virtualization must be enabled in your BIOS UEFI to actually make use of that in your operating system. So when you finish with the BIOS UEFI setup, there's an exit screen that gives you various options, such as saving your changes and exiting, or discarding your changes and exiting. So if you've made changes that you want to keep, make sure you save them. I've accidentally in the past discarded them when it didn't actually ask you, are you sure? So be careful about that. If you've made a lot of changes and you've gone through a bunch of different settings, you don't want to lose all that work. So make sure you save it. And some offer the option to load optimized defaults. So this is something that's going to come in useful if you've made a lot of changes to your BIOS or UEFI settings that weren't working properly, and you need to recover from that. So if you use this load optimized defaults, it'll get you back and help you recover from that error. So that's a useful feature. So now we're going to look at the knowledge check activity 2-1 and which type of boot authentication is most secure. Let's look at this. Power on password or supervised password. So that's nice. That's gonna that's gonna protect you somewhat. A drive password, yeah. So that's useful as well. But it's not going to give you the layer that letter C will, full disk encryption. Full disk encryption is going to encrypt everything and make it where your drive can't be accessed on another system. So that seems to me to be the most useful one. Then Windows password. Windows password is good, but of course that only protects you at the operating system level where you're logging in. So let's go ahead and take a look here. And as I thought, the full disk encryption, because full disk encryption is the most secure option because it secures the entire drive. It can't be reset by jumpers on the motherboard, and the encryption stays with the drive even if it's moved to a different computer. So that's what we talked about before. So the answer was C, full disk encryption. So now we're going to be talking about updating motherboard drivers and BIOS UEFI. So when a motherboard is causing troubles or you want to use a new operating system or hardware device, you might need to update the motherboard drivers or update the BIOS UEFI firmware. And both of those skills are going to be covered next. So device drivers are small programs that an operating system uses to communicate with specific hardware, like the different things you have, like your you've got them for just about everything. Your CD-ROM or your optical drives, just about everything needs a device driver to interact with it. So yeah, here it says the CD or DVD that comes with the motherboard contains a user guide and drivers for its onboard components. After installing a motherboard, you can install the drivers from CD or DVD and later update them by downloading updates from the motherboard manufacturer's website. And sometimes the updates are included in its updates to Windows. So when you're going through your normal Windows updates, you can get updates to those devices as well. So that's always helpful. You don't have to go seek out the manufacturer's website and download something very specific and then go through the process of updating in your device manager. So it also says be sure to get the correct drivers for the OS edition and type. For example, Windows 10 64-bit, because you don't want to confuse your 64 and your 32-bit drivers there. But that's gonna be your OS edition and type. So most people now, I would say, are probably using Windows 10 or 11 and the 64-bit version at that. So yeah, look for those when you're trying to pull information from motherboard manufacturer's website. Then the process of upgrading or refreshing the programming and data stored on the firmware chip is called updating the firmware, flashing the BIOS or UEFI, or flashing the BIOS. I've called it flashing BIOS all my life. And there's many ways of doing this. So to flash the BIOS or UEFI, always follow the directions found in the user guide for your motherboard. That goes without saying. Motherboards can use one of the following methods. You can download an update from within the BIOS UEFI itself, from the setup itself. That wasn't always a thing. Back in the old days of BIOS, we didn't have that option. We'd have to use floppy drives. Now I sound like my parents. Yeah, we used to use floppy drives and we had to flash it from there. But yeah, that was the old days. Now you can actually do it from within BIOS and or UEFI itself. You can also update from a USB flash drive using BIOS UEFI setup. Or you can run an express BIOS UEFI update, just something you download directly from the manufacturer and run it just like any other patch. So that's another option. Then, oh yes, using jumpers to clear BIOS UEFI settings. So a jumper is two small posts, two little metal pins basically that stick up off the motherboard that is used to hold configuration information. Looks just like a lot of the other pins that you see in there that you're going to be attaching, like for your the front of your computer, the face plate. You're going to have all those things for like the hard drive activity lights and everything else. They all attach to header pins on the motherboard. And there's just a couple of pins in here that'll be specified in your motherboard documentation. And those jumpers basically are used to do this reset and clear the BIOS UEFI settings. So it says here that an open jumper has no cover and a closed jumper has a cover on the two pins. Yay. If flashing the BIOS UEFI fails, a jumper can be set on it. So you normally set it and then start the system and that would clear it. So it says to learn how to set the jumper, see the motherboard documentation. But normally in my experience, what you do is you take the jumper, you'd put it onto it, start your computer to run power to it, and that would do it. So here is a graphic of that. So you can see here we've got a jumper. It's a nice big orange tannish, I don't know what you call this, like a light orange colored jumper, and it's shorting the two pins here. So when you turn it on and it runs power to it, you're going to essentially reset. It's going to clear your BIOS UEFI settings. So installing or replacing a motherboard, I know we talked about the process of gutting a computer earlier, and a lot of that still applies here. So a motherboard is considered a field replaceable unit. A technician needs to know how to select an appropriate motherboard and how to install or replace one in a desktop or laptop computer. So there's 3 approaches to selecting a motherboard, including the following. Select the board that provides the most room for expansion, select the board that best suits the needs of the computer's current configuration, and select a motherboard that meets your present needs with moderate room for expansion. So some questions to ask yourself when selecting a motherboard include the following. How is the motherboard to be used? What form factors does the motherboard use? And which brand, Intel or AMD, and model processors does the board support? And nowhere in here do I see anybody considering cost. So I'm glad to see we live in a world where money doesn't matter anymore. So some questions to ask yourself when selecting a motherboard, including the following. This is continued from 4. Which type and speed of memory does the board support? Does the board fit the case you plan to use? What are the price and warranty of the board? Does the board get good reviews? How extensive and user-friendly is the documentation, and how helpful is the manufacturer's website? And what warranty and how much support does the manufacturer supply for the board? These are all important things. It's interesting. We start off here talking about a motherboard being a field serviceable thing, and now we're talking about a lot of things as if we're buying it for the first time and considering what things to consider when buying it. But if we're servicing something that's already been bought and we're having to replace it, we're not going to have to consider any of this because we already have this equipment. It's already it was working on the motherboard. Motherboard is now bad, so we're replacing the motherboard. But but these are things to consider when you're selecting the motherboard for the first time. So the general process for replacing a motherboard is as following. And this is, again, something we kind of talked about in the first module. But we need to verify the right motherboard is selected. That's a no-brainer. Get familiar with the documentation, features, and settings. Remove the components to reach the old motherboard. Install the I/O shield, which is the shield that covers your input-output ports on the back, like your USB, your network port, things like that. Then you're going to install the motherboard itself, making sure it docks into that I/O shield that you have. You're going to install the processor and the processor cooler. You're going to install the RAM into the appropriate slots on the motherboard. Attach the wires and cabling, like the case switches, the power supply, the drives, the headers for the front panel, things like that. Then the general process for replacing a motherboard is as following. Continued. You're going to install the video card on the motherboard if you're not using integrated motherboard, but if you're a gamer, you're probably using your own souped up video card. Plug the computer into a power source. That would be very helpful. Boot the system and enter the UEFI BIOS setup. Observe your post and verify that no errors are occurring. Make sure that your memory is checking out. Make sure that your CPU, your speed and everything is set properly. Verify that Windows then starts without errors. Make sure you're not having any problems pop up when you start to boot up. Install the motherboard drivers into your functioning Windows system. Then you need to install any other expansion cards and drivers that you may have. And then you need to verify that the system is operating properly. Make final operating system and BIOS UEFI adjustments. Let's see. Oh, and then we get to knowledge check number 2. So here it says, after trying multiple times, a coworker is unable to fit a motherboard in a computer case, is having difficulty aligning screw holes in the motherboard to standoffs on the bottom of the case. Which is most likely the source of the problem? Number 1, the coworker is trying to use too many screws to secure the board. Only 4 screws are required. That seems a little bit not the answer because he's having trouble aligning the screw holes. If you hear aligning, you should be thinking, doesn't seem like you got the right form factor. And boom, number 2, the form factors of the case and the motherboards don't match. I'm putting my money on that one. Then the third one is the form factors of the motherboard and the power supply don't match. That's not making any sense to what we're talking about here. We're talking about having trouble screwing it into the chassis. So D says the board is not oriented correctly in the case, rotate the board. That's a very interesting thing, but it runs against logic, because if you think about it, with your IO, with your IO shield and your IO ports only being able to go one way, pretty much you have it in the right direction. It's most likely not this answer, unless you've been drinking very heavily. So the answer is going to be B. The form factors of the case and the motherboard don't match, and that's exactly what we thought. So form factors are designed to have the motherboard screw holes align with the standoffs in the case when they match, and that's exactly what we thought. So in summary, now that the lesson has ended, you should be able to describe and contrast various types and features of motherboards, configure a motherboard using BIOS UEFI firmware, maintain a motherboard by updating drivers and firmware, using the jumpers to clear those settings, and replacing the CMOS battery, even though we didn't even talk about the CMOS battery. But just know that there's a CMOS battery. It's like a CR2032. It's a little coin-sized battery that goes into a little place on the motherboard, and that holds your BIOS information. So if you ever take that out, you're basically wiping out your BIOS information. Yeah, so we'll talk about here in the summary and not in the main area. So then we also learned to select, install, and replace a desktop motherboard. So that is it for this lesson. I hope you've enjoyed it. If you have any questions, feel free to reach out, and I'd be happy to talk to you about it. Other than that, have a great day.